Okay, so we are moving into chapter 2. We're going to talk about domain and range first. Domain is actually what we were looking at in our last chapter with our number lines, where you scan from left to right and you write it in interval notation. We're going to do that same thing here, but we're also going to add in the range, which is the vertical scan, which you start at the bottom and scan towards the top. So the domain is your x values, and these are your y values. Now, a couple of things when you're writing the domain, if it's a list of numbers, we need the fancy parentheses. Okay, so that's these ones. We list in increasing order. And we don't write repeats. So if there happens to be a couple threes, you don't have to write them 2 or 3 times, you just write it once. Now this is just if you have a list of numbers. Okay, if you have a continuous graph, we're going to use interval notation, and we'll see that as we kind of go along. But today we're going to be more focusing on those individual points, and I'll give you 2 examples right here. So function, we'll get to that in a second, but let's list the domain and the range on this right here. Okay, so the domain again are the x values. We need to write them in an increasing order, and we don't want to write down repeats if there are any. Okay, so it looks like they currently are in increasing order. So we've got -2, 1, 4, and 8. I'm going to ask you to do that on the test. On the y values, we need to write them in increasing order and don't write repeats. We write the number, but we don't write a -4 again because we've already listed that that's in the range. Okay. So that's from a table. This next one right here is really talking about the same thing. It looks a little bit crazy, but the arrows are just pointing out which numbers go together. So if we listed the coordinates, we would have 5, 3 as the first point. What would the next point be? Yep. There's 2 more points. Okay, now let's talk about whether or not these are functions or not. We didn't list the domain and range on that second one, but I think you understand the idea after seeing that one. A function. A function means if you draw a vertical line anywhere, it won't pass through the graph more than once. So if crossing through twice is bad. Let me give you a picture example. Let's say you had a graph that looked like this. Okay? Now it's called the vertical line test. So what you're doing is you're drawing vertical lines, imaginary vertical lines, through the graph, and if it hits twice, for instance, right here and right here, this is not a function. So the vertical line test tells you whether or not something's a function or not. Well, there's an easier way to do it, especially when you have just ordered pairs like this. What value repeated would be bad? The x's or the y's? Yeah. Well, let's actually look right here. These 2 points right here, what value do they have the same? Their x value or their y value? Their x value is the same, right? It's this x value right here. Okay, so if there's repeated x values, it is not a function because you're going to have a point on top of another point, and then it won't pass the vertical line test. Okay, so let's look here. Do we have any repeating x values on this one? I'm seeing both yes and no. Do we have a repeating x value in that list of numbers? Right here and right here. So this right here tells you that it is not a function. Was the first one a function? If you look at your x values, are there any repeats? No, so this one is a function. Okay, if your homework problems ask you to write a relation, they're really just asking you to write it as ordered pairs. It's just a side note right there. Now on these homework problems, they're going to have a bunch of things that they want you to do. I really just want you to list the domain and range and tell me if it's a function or not. The other piece that they're going to talk about is this one-to-one, onto, both, or neither. We're going to ignore that part of the homework, so don't do that part. All right. We're also going to talk about whether something is discrete or continuous. So this has a domain of individual points. Okay, so this is what the graph would look like. There's a point here, there's a point here, maybe a point here, and then another one down here. Okay, that's discrete. Just a bunch of ordered pairs like we were looking at before. Now if it's continuous, it's either going to be a line or some sort of curve that goes on, but it's not just a set of individual points. We're going to look at these a little bit more later. Like I said, we're focusing more on the discrete functions today. Questions on that? So this is really the first part of the homework, and also going to be on the test, is this function stuff. And then we're going to look at one other piece. That's review. You ready? All right, so here's the last piece. This is also review. I'm sure you did this in Algebra 1. It says evaluate the function. So they give you two functions, and then they say find f of -3. Somebody tell me what I'm supposed to be doing with -3. Yeah. Which one? Yes. Okay, so the f on the outside just means make sure you're looking at the right function, not the g of x, but the f of x. So we take f of -3, and then what do we do? What do we write? -4, parenthesis, -3, and then -8. Okay, so you're replacing or substituting that number in for all of the x values. So when we simplify this, let's do the whole thing in our heads. We really have what here? 12 minus 8, 4. G of 5. Okay, so now we're looking at the bottom function. We have G of 5, -2. It's always a good idea to use parentheses when you're substituting a number in. We'll take this one in a few steps. All right, so here we've got a square first, and then we multiply by -2, -50, -20, plus 1, -69. So no matter how many x variables there are listed in your function, you have to replace every single x with that number they've asked you to. Yep.
Do you rewrite the g of like 5?
You certainly can. G of 5 is equal to -69. One left. f of 2/3. Okay, so again, the top function, -4 times 2/3 minus 8. Okay, we're not going to use our calculators on this. I'll give you a little refresher on fractions. So when you take 2/3 and you're multiplying by 4, you're really multiplying by 4/1, right? Do we need a common denominator when we multiply? When do we need a common denominator? Just add and subtract. Okay, so we multiply straight across and we get what? -8/3, which is really what is a mixed fraction? -2 2/3. Now let's think about this. We got -2 2/3 minus another 8. So we're in the hole 2 2/3 and we subtract 8 more. -10 2/3. Questions? There's really kind of two pieces of homework here. The domain and range and the function stuff, and then a few of these example problems.